Hey guys, okay, well we're back and today we're doing the addition or subtraction method for solving linear systems. And so I think the video that you saw, you watched like the first part of it because the second part of it is what we're going to be doing next time we have class. Some of these teachers are pretty cool and I'm afraid you're going to want to trade or substitute me in for one of them. But okay, just to prove that I'm not super boring, here we go. Pay attention now. It's time to start learning about the addition subtraction method. Good luck clucks for you. Here we go. Okay, substitution method. Or, sorry, addition subtraction method. All right, so today we're going to do some of the things that our YouTube teacher showed us. If you have two linear equations, you can line up the similar variables. Now these are already lined up for us. X over x, the y over the y, and you can just add all of these as though it's an addition problem. I mean, you can put this here and pretend like you're just adding in columns, right? So 1x plus 1x, there's no invisible ones, is 2x. And 1y minus 1y, 0, no y's. Not even going to write anything down. I'm just crazy like that. And then 7 plus 3 is 10. Okay, now divide by 2, and I get x equals 5. Okay, so I'm going to put that as part of my answer. X is 5. Still have to find y, and it's really easy to find y. You just pop 5 back into any one of these equations, any one of them, put it where the x is, and then solve it. So, okay, I'm going to put it in this one. 5 plus what equals 7? You can do that in your heads. It's 2. Okay, so y is 2. To check it, you can put your x and your y back into your equations. 5 minus 2 equals 3. Yep, it worked out just fine. So see, that's not so bad. I can see my calibration's off, but we're just going to keep going. Okay, now in this one, they're already lined up, n's over n's, m's over m's, and now if I add them together, I'm not going to be able to get rid of any of my variables. That's what I really want to do. I want to either get rid of the m's or the n's, work with one at a time. But if I subtract, then I will be able to get rid of them. If I subtract, it's like changing the signs. We did that before. Remember when we did polynomial long divisions and instead of subtracting, we said change the signs. Okay, so I'm going to change this one to negative. This will get changed to negative, and this one will get changed to negative. And 12n's minus 5n's is 7n's. And 3m's minus 3m's disappear. Not even going to write them down. And 18 minus 4, 14. Let's get rid of that 7 and find that n is 2. N is 2. Okay, that's part of my answer. I'll put it up here this time. 2 goes in here. Oops. Actually, it's a good thing I did that. Because when I look at my n's and my m's, they were in the wrong order, kind of. If you think of the alphabet, L-M-N-O, L-M-N-O-P, really, what I should have is M and then N to keep it in alphabetical order. So N is 2, put them there. Thought it was going to trick me. Oh, that might have tricked some of you guys too, so that's good. Okay, now, let's find M by putting 2 back in where one of the n's is. Doesn't matter which equation you choose, you just put a 2 in where the n is. I'm going to go with that one right there and put a 2 right there. Ooh, you can see my calibration's off. Okay, 5 times 2 is 10 plus 3m equals 4. Let's move this over to the other side. We're trying to get m alone. 3m equals negative 6. Divide by 3. m equals negative 2. Looks like it's negative 2. To be sure, I can pop it back into one of the original equations and see if it works. I'm going to do that. I'm going to pop it back into that first one so it doesn't feel left out. 12 times n is 2. Plus 3 times m, that was negative 2, equals 18. 24 minus 6 18. Ta-da! Yay, it works. Okay, let's try and look at this one. I'm going to quickly recalibrate because it's driving me crazy. It's not as bad as it sometimes is. It's actually being very good. Good. Okay. Now this one, oh, this is perfect because this one's ready to add because these two are opposites. So if I just add them up, it's going to get rid of the D's entirely. 2C plus 5D, 7C. 2C plus 5C, and then 3D minus 3D goes away. And 0 plus 21, 21. Divide by 7. And C is 3. Okay, what are my letters? C and D. Okay, so C is going to be here, D is going to be there. C is 3. Okay, now I'm going to pop that 3 back in to either one of the original equations. Find D. Oh, let's do the first one. I'm going to put 3 in where that C is. Put a 3 where that C is. And 6 plus 3D equals 0. Texas Chainsaw, to get D alone, kill off this guy first. Go wandering off by yourself. Just because you hear someone screaming. There you go. And that reduces to -2. That's our answer. And you plug it back in to make sure it works. Check it to make sure it works. I think I left plans for you to check like some of them anyway and show that you checked it to make sure that you got it right. Okay, now the last part of your assignment tells you, hey, you can do whatever you want. You can use substitution or addition, subtraction. But it's going to be smart to choose the easier one. So let's look at these and see which way would be easier. For number 19, would substitution be easier or addition, subtraction? And well, seeing as how this A is all by itself, I'm thinking substitution. I already know what A is, and I can sub all that junk in for the A. That's how I'd go with that one. Otherwise, you'd have to rearrange it all. Now, this one, well, it doesn't look like substitution because there's not one that's easy to get alone. I'm going to just real quick do the distributive here. That's a 4A. 4 times A. 4A minus 8B. And 2A plus 8B equals 8. And look at that. See right here how these are opposites. Now that's going to be easy to add.